Hi everybody. I'm not in today, but I want to make a video to help us work through today's topic. So what we're looking at today is, the other day we looked at the two different types of graphs. So you had the polar graph, you had the rectangular graph. And what I want us to understand is there's two different types of equations. And from those two equations, we can convert to the other equation. So for problems 1 through 6, we're looking at something that's in a general polar setup and we want to convert it to a rectangular setup. Or problem 7, 8, 9, 10, we have things in a rectangular setup we want to convert to a polar setup. So the key pieces that go with being able to do these problems are those super basic formulas that we have. X equals r cos theta, y equals r sine theta, and r squared equals x squared plus y squared. These three pieces are going to be constantly used over and over and over again. And as we look, primarily where are they going to be used? Well, for this section here, we're going to be using the r squared equals x squared plus y squared primarily. While down here, this is where we're going to use primarily x equals r cos theta, y equals r sine theta. Right? Because, it's in the rectangular. We got to get it into that trig setup. Right? So the key thing is this. To be able to use the r squared formula, we have to have r squared. So what can we do with problem 1? We can multiply everything by r. By doing that, we have r squared equals 3r cos theta. Right? So there's our first piece, r squared. X squared plus y squared. There's our second piece we're looking for. R of cos theta is x. So our rectangular formula is that. X squared plus y squared equals 3x. Right over here. Again, we got to get that r squared. R squared equals 2r minus 2r sine theta. Right, there's my x squared plus y squared. Right, so what do I have here? Right, there's my r sine theta, so I have 2r minus 2y. Okay, now, we want to set this up in a way that we can get that r by itself. Right, so we want to get the r by itself so that once we have r, we could get into r squared again to make into the x squared plus y squared. We cannot end with r in these equations. So what I do is x squared plus y squared plus 2y equals 2r. Right? I got to get rid of the r. So if I square both sides, right, I have x squared plus y squared plus 2y squared equals 4r squared. Right? Now that I have the r squared back in there, I can convert x squared plus y squared plus 2y squared equals 4 times x squared plus y squared. And that right there is my my rectangular coordinate. Alright, down here, get rid of r, make it r squared. R squared equals r plus 2r cos theta. Alright, there's my x squared plus y squared equals r plus, in this situation, I got my 2x, r cos theta. X squared plus y squared minus 2x equals r. Square both sides. Alright, so we got x squared plus y squared minus 2xy squared equals x squared plus y squared. There's my formula. Well, keep this going. Get r squared. R squared equals 2r minus r cos theta. Oops. And so what do I got there? Well, x squared plus y squared. I could subtract, right? What does this become? That becomes x. Right, there's x. So I can add the x over. Equals 2. Yuck, that's the grossest 2 I've ever written. Equals 2r. Square both sides. Here I got 4r squared which gives me 4 times x squared plus y squared. And equals x squared plus y squared plus x squared. And there's my rectangular coordinate equation. All right. Little twist here. All right, so we got a super basic equation. We got r equals 5. So if we square it, r squared equals 25. Oop, my bad. Not right that. All right, so if I raise to the second power, I got r squared equals 25, which gives me x squared plus y squared equals, what am I writing? 25. All right, so now what is this? All right, understanding this idea. This is a graph where the center of the circle's at 0, 0. And we go 5 up, 5 to the right, 5 down, and 5 to the left to create our circle. And this makes sense because this polar graph is just saying that if we have our center at 0, 0 for our polar, every point has to be 5 units away. Right? So we'd have all of our extra angle measures in here, right? But no matter what, it's just telling us that every single point on that polar graph is 5 units from the center. This is telling us, right, so this is our polar. This one down here, our rectangle, is telling us we have a circle. The center is 0, 0, and the radius is 5. Same exact idea, 2 different graphs. All right, now this one, right, issue. We have secant, right? What is secant? Well, secant is 1 over cos. So if I multiply both sides by cos theta, I got r cos theta equals 2. Right? Because secant times cos is just 1. Right? What do I got here? R cos theta is x. X equals 2. Right? Pretty crazy, but if we have x equals 2, that's our entire graph right there. Right? There's our entire graph in 2 different situations. All right. Now, going the reverse way. Right? Going the reverse way. Find the polar equation given the rectangular. So we have y. Right? Y equals r sine theta equals 2. Right? We want this to be an r equals equation. So r equals 2 over sine theta, which gives us r equals 2 cosecant theta. And there's our graph. Well, there's our equation. And now I'm looking right away at this second problem, problem 8. Problem 8 is set up where I see that circle formula. I know I have a circle. The center is at 0, 0, and my radius is 4. Right, so right there, I already know what this is going to look like, but going through the process, x squared plus y squared equals r squared. R squared equals 16, r equals 4. Right? Same equation, same graph, 2 different equations. 2 different equations. All right. So there I got r squared equals 2. What does x represent? R cos theta. Divide everything by r equals 2 cos theta. All right, so what do I got here? I got r squared equals x is r cos theta squared minus r sine theta squared. All right, this gives me r to the 4th, and if I distribute, which I don't have to FOIL, a lot of people think I have FOIL, r squared cos squared theta minus r squared sine squared theta. Now if I divide everything by r squared in this situation, I got r squared equals cos squared theta minus sine squared theta. Going back to a different unit, what do we have here? We have an identity. Right? We have our identity. We have the double angle cos formula. R squared equals cos of 2 theta. To get r by itself, r equals positive negative rad cos of 2 theta. There's our final answer. All right, so over here, key thing, we must have r equals. Right, you gotta have r equals in this side. Right, going from the rectangle to the polar must end with r equals. Up top, we gotta get it at r equals. We gotta get it at r equals, and we gotta see those x's and y's that are involved in our normal rectangular graph. All right, I want to do one more together to make sure you got the general idea for what's going on here. Right, so if we're looking at problem 4, right, so slightly different here. My first move here is I'm actually going to FOIL. So if I FOIL x squared minus 2x plus 1 minus y squared minus y squared equals 1. All right, and what do I have? I gotta go from rectangular to polar. So I got all my setups. I got r cos theta squared minus 2 times r cos theta plus 1 minus r sine theta squared equals 1. Okay, so what do we got now? Right, so if I GCF, well, let me distribute r squared cos squared theta minus 2r cos theta plus, cancel the 1, minus r squared sine theta equals 0 because I subtracted over. Alright, now, if I divide everything by r, I got r cos squared theta minus 2 cos theta minus r sine squared theta equals 0. Alright, so remember, I'm trying to work this out to get this into an r setup. So this piece doesn't have r, so I gotta move it over. R cos squared theta minus r sine squared theta equals 2 cos theta. GCF the r cos squared theta minus sine squared theta equals 2 cos theta. All right, old unit, there's our identity again. R double cos formula. 2 cos theta. R equals 2 cos theta over cos of 2 theta. And that's our final polar setup. Alright, so you have that classwork, work through that classwork. You have this homework, you have the answer key to this homework, check things over, and when we meet in class, we'll look it all over and make sure we're okay. Have a good one.